So we decided that the next set of videos might not be best as new prerequisite videos, but more so kind of going back and looking at common misconceptions or misunderstandings based on what we've seen in the most recent quizzes. So from quiz 7 as an example, we're looking at a couple of things that happened here, and I want to make sure that I'm clear that anything you see on this paper right now in purple is actually not correct. But I want to talk about why and why it's obviously put down here. So two of the most common things we saw with this problem, the first problem that was on the quiz, was the lack of understanding of what the logarithmic properties were that were supposed to be used in order to expand this expression. So what we're looking at for this example here, this was something that a lot of students did, which was they assumed that if you have the natural log of a product, and don't forget product meaning when we're multiplying factors, that you just take the natural log of each of those factors and you continue to use the product. That in fact is not true. And I'll just go ahead and state right here that the natural log of a product of A times B is not the same thing as the natural log of A times the natural log of B. What we do know is that the natural log of a product is actually the sum of the natural logs of those factors. So to correct this situation, had the student put plus signs in here instead of multiplication, this would have been a correct statement. Okay. Now over here, this was another common mistake that we saw, which was students broke it down properly using the sum, but they only took the 2x cubed together and then the e to the fourth separately. So this actually is okay so far. All right, but then here's where the error came in. A lot of students took that exponent of 3 down as the coefficient. Now that would have worked if we were looking at the quantity 2x all being cubed. Okay, but the problem is the 2 is not being cubed in this situation. We don't have the quantity 2x cubed. We have 2 times x cubed. So those two things are not the same. And because those are not the same, we cannot bring the 3 down as the coefficient on the logarithm if the 2 is still inside. Okay, and so basically, if we were going to rewrite this thing, right, in its correct form, we would do so by, sorry, I thought I had my green marker out, 1 second. Saying we have the natural log of the first factor 2 plus the natural log of the second factor x cubed. And then if you want to put parentheses on that, you may. And then plus the natural log of the third factor, which is e to the fourth. Now this would be correct. Okay, this would be the correct expansion using this property here, which says the natural log of a product is the sum of natural logs of those factors. Now I can't clean up the natural log of 2. There's nothing I can do there, so I'll leave that alone. But in this second term, I do have that coefficient, which I can bring down, right? That power to coefficient property. And then I should remember that the natural log is a log base e. So the log base e of e to the fourth, and this goes back to 2 days worth of worksheets, just reduces to 4. And so that is the cleaned up form of what the expansion should be for that number 1 on quiz 7. Okay. All right, so let's go ahead and look at the last question. I'm actually not going to take the derivative, but on the quiz, you were asked to take the derivative of this function here. 2 major misconceptions. It's actually 1 misconception written in different ways, okay? And that is students think that we are multiplying by ln, all right? And that is not what we are doing, all right? Let me give you another example of what I'm thinking here. So if I have x, let's do this, 4. If I want to take the square root of 4, right, I write that the square root of 4 is equal to 2, correct? So if I write that the square root of 4 is equal to 2, I think everybody would agree that that's true. Okay. Now, Do I write that 4 times the square root of nothing is 2? No, because I don't know what I'm taking the square root of here. Okay. Do I write the square root and then the 4 next to it and say that that is equal to 2? No, I do not. So this is a situation where I'm trying to get you to understand the square root is a function, right, that I am applying to the 4 to get 2. The square root of 4 is 2. The natural log is the same type of thing. It's a function that I am performing on an argument. Okay, so it's not that I'm taking the natural log times y. That doesn't have any valid mathematical meaning. It's that I'm taking the natural log of y and the natural log of the sine of x, which is raised to the x power. Okay, so here, this one is a little bit worse because if I put the natural log over here, right, I say of what? What am I taking the natural log of, right? So the natural log is the function and it needs an argument on which it's going to perform its action. Okay. Another example would be, if I want to square something, can I just write nothing squared, right? Let's do this. Nothing squared equals 9. Well, that doesn't make any sense, right? What am I squaring to get 9? It's 3, right? But I wouldn't write 3 times nothing squared, right? That doesn't make sense. So the natural log is a function that I am performing its operations on an argument. And I have to make sure that I'm very careful in the way that I write these things. There should be no multiplication symbol here whatsoever. And I surely can't write natural log with no argument inside. Okay, so those are two of the biggest misconceptions that we had. And so based on that, I just wanted to go back through the properties of logarithms that we are supposed to have kind of down pat from algebra class, okay? And the first one, again, is the natural log of a product can be expanded into the the sum of the natural log of those factors, okay? I also know that the natural log of a quotient can be expanded into the difference of the natural logs, okay? And then the last one is if I have the natural log of something raised to a power, that it has to be a quantity raised to a power, then I can bring that power down as the coefficient on the logarithm. Okay, and so it's very important that we make sure that we are, performing valid algebraic steps to get through the calculus. Otherwise, none of the calculus is going to be correct.